Hey there, welcome back to my big data tutorial. I'm Shiva, and today we are diving into an exciting educational journey. In this video, we are going to unravel the mysteries of big data problems and its requirements, and by the end of it, you will have a solid grasp of the key concepts. Whether you are a curious beginner, so no more delay, let's get started with the topic big data problem and its requirements. Today's agenda is big data problems, and we'll see its data types, what are the different data types in big data, and two ways of building systems. Okay, so here we have different types of data that will be generating in big data. As if you have not seen our previous video, I'll suggest you to please go and check that video first. Then you will understand better. In last video, I have explained about the big data and its component. And now today we are going to start, we are going to see what are the different types of data in big data. So as we can see on the screen, there are three different types of data. One is structured data, second one is semi-structured, and third is unstructured. Structured data means what? The data will be in a structured manner. If you can see here, first name, last name, order ID, and order total. So all the first name will be in the first name column, and the last name will be in the last name column. Order ID is in order ID column, and order total is in order total column. So these are the structured data. This is very easy to understand, very easy to maintain. So this is called structured data. But how we are already using structured data in the form of Excel. Okay, so this is structured data, like the data will be in a structured format. Okay, now we'll move to the semi-structured data. Semi-structured data means the data will be in this format. See, in key value pair format. These are CSV files, and your data will be stored in this format. Why? Because see, if we were storing the data or data in this format, it was taking more space on the hard disk, or more space, actually we can say storage space. But whenever we started storing our data in this format, in semi-structured format, it is taking less amount of memory. So this is called semi-structured data. To make it readable, we have to convert it into different format. Then only we will be able to read. Like, okay, now we are able to understand what it has been written. But see, in the structured data, what is happening? We can easily understand. Like a first data, it's in the first data column, first name column. Last name is in the last name column. But now here you can see all the things are different, like a key and value, key value pair. Again, the next cluster will start, or next will start from the, again it will be first name and we can say key value pair. So this is called semi-structured data. Okay, and this is called unstructured data. Unstructured data means a data present in absolute raw form is termed unstructured. Like, see, this is the data. This is the mixed data. Like in this data only, we can see there is date and time, and it is giving the what is the GMT, and other things are there also. So these are in the raw form, and we have to make it structured, and then we need to store. So our big data should be capable of handling all these types of data. But if I talk about the traditional database management system, it is not capable of handling these all types of data. They will be only handling structured or somewhat semi-structured data they are able to handle. But it is not able to understand, it is not able to handle unstructured data. Okay, so this is the three different types of big data. Structured data, like your data will be in a structured manner. Unstructured data, like your data will be in key value pair, and unstructured data, like semi-structured data will be in key value pair, and unstructured data will be only raw format. We need to divide it and store it into different forms. So, and our database should be capable of handling this all type of data. Okay, these are the types of data. Now, one more requirement is what, like whenever we are generating, like our system and like nowadays generating this much amount of data, we must need a storage, a large storage where we can store large amount of data. Okay, so this is the need of, this is the problem, these are the problems what we are looking now. Like whenever it is a big data, whenever it is generating a large amount of data, that then the first problem is like storage. How you will store, where you will store. If we know that storage memory is very costly, how you will store that much amount of data. Okay, so these are the problems. Okay, processing is another problem. If we have a large amount of data, it will take large amount, like it will take much time to manipulate or process those data. Traditional systems are not capable to handle this much amount of data in efficient manner. Okay, now scaling. Traditional systems have serious limitation in the scaling system to accommodate capacity requirement. Like if we have a system, see, if I talk about this is the system. So if you want to increase, this is a server, if you want to increase the server capacity, then you need to spend very much amount of data. Like it is very costly to expand. But so these are the problems, these were the requirements. Like we need something which can help us in scaling, easily scale. Which can help us in easily scaling the capacity of our systems. Okay, so this is called scaling. Now there are two ways of building systems. What are those two ways? One is monolithic. In monolithic, one powerful server will be there with a lot of resources. Okay, only one server will be there, but there will be, it will have a lot of resources like a memory, RAM, and processors. So all the things will be at like a very high amount, or like a large amount, like or high, we can say high configuration system should be there. This is called monolithic. We do have another type of system that is called distributed system. Many small systems connected and working as one entity, that is called distributed. We can see here these all are connected with with each other, and these all are working as one entity. We'll see it about it, how this will increase the capacity of storing the data, capacity of manipulating the data, capacity of processing the data. Because if we are scaling one powerful server, so how much we can scale it? There will be a serious limitation also. There will be a certain point. After that point, you cannot scale it. But here you can see there all the systems, like all the systems are connected together, and these all are working as a node. Okay, and all the system have different processor, and all are used, like all the system will be used for a parallel processing. Okay, all the system will be used for a parallel processing. So this is called distributed. Distributed HDFS means Hadoop distributed file system, means it will distributed. See, distributed, and we'll talk about later. Like we'll see what is the meaning of HDFS. But here I just want to explain you how we can develop a system in distributed manner. Monolithic or distributed? What you will suggest? We'll see. Monolithic or distributed? Monolithic, a single powerful server, hard to add resources after a certain threshold. After a certain threshold, we will not be able to expand or increase their capacity because of their limitation. Okay. Now, or what are the resources? See, RAM. This is the resources RAM. So how many RAM you will include here? Okay. So this is also a limit. Hard disk, 1 TB storage. CPU, quad core compute. So how many CPU we can? Only one CPU or two, or like how many CPU can be added? Not 300 CPU cannot be added. Okay, 300 processor cannot be added in one server. How many hard disk will be added? How many RAM will be added? So there is limitation. Only 1 or 2, maybe 4. That much RAM you can add. Is monolithic scalable? No. Means if I talk about monolithic is scalable, can we increase their capacity easily? No. 4x resources, it means, just take an example, and this is 4 GB RAM, 1 TB hard disk, and one processor. If we increase its capacity like 16 MB RAM, 16 GB RAM, 4 TB hard disk, and 4 processor, can it be scalable? Is that? No. So add one more thing is after increasing their capacity, will it work like a 4x resources is equal to 4x performance? No, it will not. If we increase their capacity at 4 times also, then also it will work in a sequential manner. Okay, so if you give one task to this system, it will manipulate or analyze one by one only. Okay, in a sequential manner. But in case of distributed, these are the cluster with nodes interconnected. These are all system are nodes, and all the nodes connected with each other create a cluster. Okay, what it creates? It's a cluster. Many cheap hardware from cluster. See, all the systems have a very cheap hardware. Like these are all. Its hard disk will be used for a storage, and its a RAM will be used for a processing. So these are the things very easily scalable. Many cheap hardwares. Okay, is distributed system scalable? Yes, distributed systems are horizontal scalable. Okay, we can increase their capacity as many as node we want. We can add that much system. Okay. Now distributed systems are scalable. How it is scalable? If I have increased its capacity to 4 times, it means there will be 4x resources. It means there will be 4x speed. Because why? Because all the fours will be all the cluster will be used in parallel processing. Will use as a work as a parallel processing. So whenever you are giving any task, so there will be 4 different a different cluster or 4 different resources will start working on that. Okay, so that is why a speed will increase at 4 times. Okay, monolithic or distributed? What you will choose? Monolithic is architecture. Monolithic architecture, it will be vertical scaling up. You can increase the capacity of that server only. You cannot create another server. Okay, but in case of distributed architecture, horizontal scaling called. This is called scaling out. This is monolithic called scaling up, and horizontal scaling called scaling out. Okay, monolithic or undistributed, distributed only because of the easily storage. Okay, all goods big data systems are based on distributed architecture. So this is the end of this session, this video, and there you have it, a comprehensive exploration of big data requirements and its problem. I hope you have enjoyed this video as much as I have enjoyed creating it for you. Remember, learning doesn't stop here. There is a whole world of knowledge waiting for you. So keep exploring, keep asking questions, and keep that curiosity alive. If you found this video helpful, don't forget to give it a thumbs up and share it with anyone you think might be benefit from it. Your support fuels our passion for creating more educational content. And if you haven't already, be sure to subscribe to my Big Data Tutorial channel and turn on those notifications so you never miss out on our latest videos. Thank you so much for watching, and until the next time, keep learning and keep growing. This is your dear Siva from Big Data Learning, signing off. Thank you.